So now the last couple of videos were kind of related to this. We looked at active and passive buzzers, and the last video we looked at an Astable mode 555 timer that I was able to adjust with the trim pot, although I'm using a different value resistor there and capacitor for the timing. The timing capacitor that I was using, I have to the supply rail. That's just to help steady the voltage in case I bump the power supply or whatever. So it is set to 5 volts. I'm going to turn the power on, and you should be able to hear the clicking. And we zoomed closer. Hopefully you can hear the clicking better now. There is the clicking. We can adjust how fast it clicks. So right now I have the trim pot to the maximum resistance that I can get. I'm going to lower it. And there you can see we were able to get the trim pot from a click to faster clicks. And we could even drop it down enough to get a buzz right there. So now we'll zoom into the schematic that I drew a long time ago. So that will kind of influence the values where I may not know exactly what I was aiming for or trying to point out with them. But in any case, this capacitor, again, just kind of keeps the supply voltage the same to the breadboard. If I bump like the power supply or we have sudden like current changes, that can sometimes throw things off. But this capacitor stores a charge. And if voltage tries to drop, it starts delivering that charge to like maintain the voltage until it like discharges. Then of course voltage goes down. But by then the power supply kicks back in. So in any case, this is just kind of extra 100 microfarad, larger value. Usually the better, but this is probably good enough. Now we have the resistor there, 220 ohm resistor, and then that has a orange jumper that comes to the trim pot. It also goes to the discharge pin, but when the output is high, so that's one of the clicks, then the pin 7 there, the discharge pin, is not conducting. Basically it's off. It's like it doesn't exist when the output's high. When it's low, it connects to ground. Then it really exists. All current through the resistor goes to ground. But when the output's high, when the capacitor is meant to be charging, so its voltage is going up, then current has to go through that resistor and then to the trim pot. So this is wired as a variable resistor. There's 3 pins, and the middle pin is the wiper. So it's all the way up to this corner here. So we have to go through all of the resistance before we get to the jumper. So this will be when it's going slow, when you hear the clicks. And so that charges the capacitor. When it gets to 2/3 supply voltage, that's the threshold pin of the 555 timer. It notices it's 2/3. Then the pin 7 connects to ground, as I said before. The capacitor discharges, again through the resistor. We get the same current path, but in the opposite direction. Then it goes to ground. Whatever current gets through the 220 ohm resistor goes right to ground. So we're working with 5 volts right now. And when the output's low, capacitor is discharging. That doesn't really matter. If it discharges quick enough, like somewhat high current goes through the discharge pin, but it should be able to handle it, especially with a 10 microfarad capacitor. But whatever current gets through the 220 ohm resistor also just goes right to ground. So we get relatively high current for the power supply. I bumped it up to 30 milliamps of current of a limit. So if I lower this, make it go quick enough, and then drop it to 20, there you can see we have periods of time where it wants to output more than 20 milliamps of current. But now we got 30 right there. And the capacitor kind of steadied things, but it cut down the current. And so ultimately, it had to lower the voltage to keep the current from going above 30 milliamps of current. Now, so, you know, topics from other videos, but something to be aware of. We need to take into account the current that's going through the resistor just being wasted when the output is low. So I don't like using this lower value resistor. Practical circuit, you'd want to use like a much smaller value capacitor and just have a higher value resistor right there. But again, it will influence what the 10K resistance does. So it adds up. We got 220. Maybe we have 0 ohms of resistance when it comes to charging. And if we slide it over, maybe 10,000 ohms of resistance. And trim pots are not precision components. It's not exactly 10,000 ohms between the wipers. Usually it's like higher. Maybe it's like 11,000 ohms. But the takeaway is you can adjust it. That's the main thing. And it should be at least 10,000 ohms, probably a little bit higher, maybe a little bit lower or something if you got the wrong end of the deal when it comes to the tolerance. But I think they're generally higher. So in any case, instead of rambling on about that, 10 microfarad capacitor, that sets the timing, both the capacitance, how much resistance it has to go. So again, if we put the wiper all the way to connect to that end of the resistive element, then the capacitor will instantly discharge. So it will be low for a very brief period of time. There's also like a little bit of resistance where the connections are and stuff, but it's almost like no time at all if you put it directly to 7. Whereas if you go to 10K, then it'll take about as long to charge and discharge, about the same amount of time, approximately. Just a little bit more resistance for when it's charging. When it's charging, the output's high. It's connected to 5 volts, about as good as it can. When it is discharging, the output is also connected to ground right there. Both of these are connected to ground at the same time. That's an easy way to remember. And so yeah, this is an old diagram. I put the pin layout, top left. There may be 1 or 2 dimples there. You work your way down, 1, 2, 3, 4. Then you go across, however long it is. Then you go across, work your way up, and there are the pin names. I'm not going to read them off. I put a little note to point out that the way we have this wired is astable mode. So once you learn like the basic ways to wire them up, you start recognizing how they're wired up, and it's easy to adapt them to other circuits. So now, when the output is high, we already talked about when it's high and low. When it's high, it connects to 5 volts about as good as it can. And that's why we got the positive there. Actually, the reason why we got positive there, you can see this side of the capacitor, the negative, these are polarized. You got to put them in the right way. There's a gray band there, and it's shorter. The wire's shorter there if you don't cut it, but it's mostly that gray band that you can identify it from. Then that's like headed to ground. It's going through the load. It's going through the passive buzzer. You can see we got ground on that side. So that's always ground. We can get a higher voltage than ground, and we can go down to ground, but we can't go lower than that. So that's why we have the positive side over there. That's always the way to think about which way you got to put it in if you are confused, because there's a bunch of components. Now, and also changing voltage. So 10 microfarad, exact value doesn't really matter. If you have a higher value, you just kind of waste more current for the most part. And if you go too low, then maybe, it won't have enough current to get the buzzer to like make a noise. But there's like a wide range of values you could use. 10K seems to work, or 10 microfarad, seems to work all right. The passive buzzer, so it's going to let current flow through it. It doesn't really make noise because current's flowing through it. It's that change of current. So it goes high right there. Current goes. It makes, in this case, a click, and the capacitor fully charges. It stops current from flowing anymore. Things hold steady. Without the capacitor, current will just keep flowing as long as you apply a voltage. So active buzzer, that's what you want. You just want to keep feeding it current. It just keeps buzzing. Passive buzzer, you actually have to keep changing the direction. So that's what happens. The capacitor charges, buzzer makes a click. Then it just like stays there. So this prevents it from wasting current. That's the biggest thing that it is doing. And then the output goes low. It connects to ground while the capacitor is discharging. So we got a charged capacitor, and I'm pretty sure we get a click. I think you can hear a difference in the click when it discharges as well. But same thing. Power is actually coming from the capacitor then. So that's one reason why the click will sound different. And you get that click with the buzzer. Once the capacitor is discharged, the click is probably quicker than the discharge. But yeah, it will discharge, and then that's it. It's ground on both sides. No more current flows. And so you don't quite need the capacitor for that part. It's more when you got the output that is high, then that capacitor charges and it stops current from flowing. It will flow when the output's high, but not when the output's low on both sides. So you don't need the capacitor for the passive buzzer. It only buzzes when you got current flowing. But capacitor keeps from wasting current. We depend on the clicks, but we need quick clicks. So, as I said before, we got the full resistance there. And so I think half the clicks are when it's going high, half the clicks are going when it's going low. To get, you know, like a tone where it doesn't sound like clicks at all. It sounds like a relatively steady noise. They need to be going fast enough. The faster they go, the higher the pitch it will be. And also it depends on what's actually making the noise. You could do the same thing with the speaker, although I think you need a bigger capacitor. But we're using a buzzer here. Now, I think I forgot to mention this when I talked about both the active and the passive buzzer. They have a plus, and that has to be towards the more positive side right there. And when it comes to the passive buzzer, there's no epoxy in there. So yeah, I put the active buzzer away. There's no epoxy there. This is filled in with the active one right there to protect the circuitry or whatever it's for. I don't know the exact reason. But this one, for some reason, the circuitry is exposed. And I turned the power off. Power's back on. It's still wired right. So yeah, this has to be put in the right direction too, just like the capacitors right there. So, in any case, this went on a lot longer than I thought I would, but I hope you still enjoyed. I think I explained everything. Well, I didn't really explain everything. If you're still a little more confused with how the circuit works, we got the 555 timer there. It responds to the capacitor charging to 2/3 supply voltage when you first apply power, and then discharging down to 1/3 supply voltage. That is if you don't modify pin 5 right there. So you can adjust where those voltages are. I think mostly the 2/3 side. I think this connects directly to the 2/3. And then if you kind of raise or lower that voltage by different means of the 2/3 supply voltage, so it wouldn't be 2/3 anymore, but you know, the resistive voltage divider in there, it will change the 1/3 as well, but about half as much. So in any case, not going to go into great detail on that. I did in other videos. So that's what it does. As long as you leave this pin either floating or put a little capacitor. Sometimes they put 10 nanofarad. That just kind of holds the voltage steady. But like circuits like this, probably notice no difference if you added a little capacitor there. But often you will see that, but I don't want to explain that every video. Now, you can see here, so we got pin 8, so that's the positive supply. And again, you got to power the integrated circuit. And this also determines where that 1/3, 2/3 are. So pin 1 is the negative supply right there. So that's powering the integrated circuit and doing other stuff, as I said before, like the 2/3, 1/3. But that's primarily what they are, the power supply. Pin 4, you can see I got that to the positive supply. So if we connect pin 4 to ground, and I think you have to get, you know, really close to ground, so direct connection generally, then that resets the 555 timer, which means the output will be low. It will stay low no matter what's going on. Doesn't matter what's going on, it will keep the output low, and also the capacitor will just keep discharging. So it won't go high. We like get rid of that 2/3 response, or the 1/3 response. I mean, it just keeps the output low forever if pin 4 is low. So you put it at the positive supply, it prevents pin 4 from doing anything right there. So yeah, that is probably about everything. This is the I think pretty common symbol for a buzzer, but hopefully they say passive or active next to it. But if you see a capacitor right there, then you can pretty much be guaranteed it is a passive buzzer. If you don't see a capacitor, you can be pretty well guaranteed that it is an active buzzer. And I don't know, maybe some people use that for a light or something, especially if like their automobile, maybe that's like a headlight to them or something. So hopefully they got writing on there. Otherwise, when you learn how circuitry works, it kind of makes more sense what kind of load they have at the output. Because symbols aren't completely universal. They can vary from time to time. So I don't know how much these vary, but I have a feeling that there's a lot of symbols that might look like that have nothing to do with buzzers. So that I would mention that. So yeah, in any case, this was a lot of stuff. Hopefully it helped some people that are really struggling, or just beginning to learn, I should say, this kind of stuff. It is confusing at first, but once you get a general feel for the basic circuits, all of a sudden the complex circuits, they look pretty easy. There's just a whole bunch of simple concepts thrown together. So knowing how they all work together makes it easy. But if you're just trying to learn how the whole thing works and you don't have anything to go on before that, it looks really complex. So keep checking out the simple stuff until it's super easy, and then go more complex. Thanks for watching. Make sure you check out one of the other videos I posted on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.